Good evening, ma'am. Uh, this is the digital assignment one of Information Security Foundations. So, my topic is Berlekamp Massey algorithm. This is Nilmani Chandrakar. So, contents are introduction, algorithm, LFSR, specific areas of application, conclusion, and references. Now, introduction. Uh, Around us, data is moving faster than ever. There is a sensitive data is also part of our life. We use encryption to protect our data. Encrypting the data changes it in a way that makes it useless to potential reader, but it can be restored to its original state once it reaches its intended recipient or legitimate recipients in a secure manner. The Berlekamp-Massey algorithm is an algorithm for determining the linear complexity of a finite sequence and the feedback polynomial of a LFSR, linear feedback shift register of a minimal length, which generate the sequences. This algorithm is due to Massey, who saw that the iterative algorithm proposed in 1967 by Berlekamp for decoding BCH codes can be used for finding the shortest LFSR that generates a given sequence. Uh, Algorithm, Berlekamp-Massey algorithm. Massey algorithm is a primary function is to assess binary BCH codes. This algorithm's ability to decode a message using only a small piece of encoded message makes it helpful. The most important step is to rephrase the issues such the explicit consideration of n by n matrices is avoided due to the excessive labor and storage required for such an operation. Both Massey and his variants of methods and Berlekamp essential equation were used in this reformulation. Uh, this algorithm takes input as a binary sequence S of n and generates a linear complexity of length L. Here we initialize the C of D. It's a connection polynomial initialized with 1, length initialized with 0. Then we perform this second stage while n less than n, do the following these operations. Then it finally return L. By using the physical interpretation of the linear feedback shift register as a tool to better understand the algorithms, Massey improved and expanded its application and in implementation. The version produced LFSR with a predetermined output sequence. Linear feedback shift register are a technology used in cryptography to increase the efficiency of cipher. When one considers what a feedback shift register truly perform, the nomenclature used to describe them is extremely suitable. Linear feedback shift register are, in the simplest sense, devices utilized in the encoding and decoding of a sequence using a straightforward linear formula. We must first decide on a size n for the linear feedback shift register, where n is both the number of coefficient and the size of initial seeds. So choose starting state s, seed s, 0 s of 0 to s of n, and c of 0 up to c of n minus 1. On the other hand, linear feedback shift register is a special type of recurrence relation where the preceding term are not raised to powers, there are no added constant. For example, here s of n equals to s of n minus 1 plus 1 is not a LFSR because here 1 is added, constant term is added, and other one is s of n minus 1, s of n minus 4, s of n minus 5. This is LFSR because there is no constant term. It's a fifth order LFSR sequence. The order is also referred to as the number of registers. This is a sequence formula of LFSR. Now, as specific areas of application, the algorithm, as mentioned above, deals with decoding binary BCH codes, including Reed-Silmon codes, were fortunately for Berlekamp extensively employed at the time. His approach was published in a number of different disciplines. Instant interest was generated by his algorithm, more effective method of deciphering these kinds of codes. Its approach has been used a decoding tool for everything from CD player to NASA deep space communication protocols. LFSR is mostly used in stream cipher to generate pseudo-random sequence. We are aware that LFSR can produce an endless bit stream. The most popular way to create stream cipher is by combining many LFSR. This is LFSR variants of Fibonacci variants. Here we add previous two terms. So here we pass seed and tap and seed value. So shift register XOR outputs, and the results are result for iteration 0 1 shift register state 11. It tells iterations and shift register states. Now, conclusion is, as you can see from this algorithm's formulation, comprehending it is a difficult procedure. This has allowed me to fully forward my efforts in that direction, knowing the Berlekamp Massey algorithm and demonstrations of it. Now I'm ready to consider algorithm implementation. Learning about this concept as a programmer bring me a fresh perspective on some coding issues, because Berlekamp is mostly used in a to solve a recurrence relation problems. However, adopting ready-made methods and standards for encryption in security criticals projects is always advised, as an expert in the field of cryptography are likely to develop a safer and more efficient solution than a passionate enthusiast. These are the references we have used in for this DA. Thank you.